Suppose that there are 3 roads from town A to town B and 2 roads from town B to town C. How many different routes are there from A to C that pass through B? To help us understand this problem, it's going to be very easy to solve it if we look at a tree diagram. So I've got a point A on my tree diagram. There are 3 roads that get us to B, so what you see is 3 lines on the tree diagram. Then from B to C, there are 2 roads, so from each one of these B's, you see 2 more lines that lead to C. What we're interested in knowing is how many different ways can we trace through the tree diagram. So from A to B to C on the top branch, or any of these others. What you'll notice is that there are 6 choices along the side here, and the way that happens is because we had 3 routes from A to B, 2 routes from B to C, so the total number of ways we could do this was 3 times 2, or 6. We can think of this as a bunch of choices. When you're deciding whether to go from A to B, how you're going to do that, you have 3 different roads that you can pick from. So you have 3 choices. Once you get to B, there are 2 more choices. And so essentially what we're noticing here is that to go from A to C requires you to make 3 times 2 different choices. This is essentially what the multiplication principle tells us. Suppose that n choices must be made, with m1 ways to make choice 1, and for each of these ways, m2 choices to make choice 2, and so on with m sub n ways to make choice n. Then there are m1 times m2 all the way up to mn different ways to make the entire sequence of choices. So essentially our numbers of choices multiply together. So when people ask us how many ways there are to order something or how many ways there are to do something, we have to break it down into a series of choices. The menu at a local restaurant offers the following options. For appetizers, there's nachos, pub chips, or wings. For drink, coffee or iced tea. Entree, burger, fajitas, meatloaf, or pot pie. And for dessert, there's a brownie sundae or tiramisu. How many different dinners are possible if one choice may be made from each of these 4 categories? So let's take a look at what our possible choices are. There are going to be 4 choices. We need to choose the appetizer, the drink, the entree, or the dessert. So to begin with, we have to figure out how many ways are there to choose the appetizer. Since we're choosing from pub chips, nachos, or wings, there are 3 ways to do that. For the drink, there are 2 ways to choose it because we're choosing from coffee or iced tea. So we multiply by 2. For our entree, we're choosing from burger, fajitas, meatloaf, or pot pie. There are 4 ways. And for a dessert, we're choosing from brownie sundae or tiramisu, so there are 2 ways. So the multiplication principle says we multiply out the numbers of ways to do these things, and so that gives us a total of 48 different dinners that we could choose from. Let's look at another example. The college uses 3-letter codes to represent the department on the class schedule. For instance, the math department is denoted by the letters MAT. How many different 3-letter codes are there? So we're going to break this down into 3 choices. We need to choose the first letter, the second letter, and the third letter. So when I go to the first letter, I can choose from any of the letters in the alphabet, so I have 26 choices. When I go to the second letter, I can choose from that same 26 letters, so I have another 26 choices. When I go to the third letter, same thing. So when I multiply 26 times 26 times 26, I get 26 cubed, which means there's 17,576 ways to choose the letters. So there could be up to 17,576 departments at the college. Luckily, there's not nearly that many. How many license plates are there that consist of 3 letters followed by 3 numbers? We need to break this down into a series of 6 choices. The first 3 choices give me the number of ways to choose the letters. The second 3 choices will give me the number of ways to choose the numbers. So when I choose the first letter, I'm choosing from 26 different things, and the same for the next 2 choices. So the number of ways to choose the letters by themselves are 26 times 26 times 26. It's a lot like the previous example. Now when we choose our numbers, we have 10 numbers to choose from. So 10 times 10 times 10 tells me the number of ways to choose those 3 numbers. That means the total number of different plates is 17,576,000. Now some states like California don't use this because they ran out of this number of plates years and years ago. Now let's change the problem a little bit. How many license plates are there that consist of 3 different letters followed by 3 numbers? So this means the first 3 letters cannot be the same, but the second 3 numbers can be the same. So we still have to choose our letters and numbers, 6 choices. And for the first letter, we have 26 things that we can choose from. When we go to the second letter, we've eliminated the letter that we got on the first one. So now we have only 25 things to choose from. And on the third letter, we'll only have 24 things to choose from because the first 2 letters have been eliminated. Now when we come to our numbers, though, we still can choose from 10 numbers. So we get times 10 times 10 times 10 because we're not eliminating any of the numbers. It didn't say those had to be different. So when I multiply these all together, I get 15,600,000 different license plates. Now let's require that we have different letters and different numbers. So now when we make our choices, we're still choosing letters and numbers, 6 choices. But now the number of the ways to choose the letters is 26 times 25 times 24. And now when we choose our numbers, we'll start with 10 things to choose from for the first number. But when we eliminate that number, the next choice will only be 9. And then the third choice here for the numbers will be 8. So when we multiply 26 times 25 times 24 times 10 times 9 times 8, we get 11,232,000 different license plates. How many ways is there to rearrange the letters in the word goat? In this example, we need to decide, are we going to be allowed to repeat letters or not? And when it says rearrange, once you've chosen the position for one of those letters, you can't use it again. So we're looking for things like goat or like OGAT or TAOG, but we're not going to be allowed to do something like GGAT. So we need to make 4 choices here. The first thing we're going to do is we're going to choose the first letter. Since there are 4 things to choose from, G, O, A, or T, we put a number 4 for that first choice. But since we've now chosen a letter for the first place there, now we only have 3 things to choose from for the second letter. Now we've chosen those first 2 letters. Now there's only 2 things to choose for the third letter. And once we've chosen the first, second, and third letters from the word goat, there's only one way to choose that last letter. So when we multiply these decisions together, 4 times 3 times 2 times 1, that gives us 24 different ways to rearrange the letters in goat. Now let's change it a little bit. How many 3-letter words are possible if the letters are chosen from the word goat? Now I'm not saying rearrange, I'm just saying 3-letter words, and when I say words, they don't have to actually spell out anything, but 3 letters in a row. And in this case, now I'm just saying pick them from the word goat, you can repeat. So we have three choices because it said three-letter words. And for the first letter, there's going to be four choices, but also for the next two letters, because in this case, I didn't say they had to be different. I didn't say that you were rearranging. You need to read this very, very carefully. So 4 times 4 times 4 gives us 64 different ways to pick three letters from the word goat and to make words out of them. How many three-letter words are possible if three different letters must be chosen from the word goat? So now I'm going to have three choices, but when I make my choices, once I've chosen a letter, I can't use it again. So there's 4 ways to choose letters from the word goat, but once I've chosen the first letter, there's only going to be 3 ways to choose the next letter, and then 2 ways to choose the last letter. So I get 4 times 3 times 2, which is also 24 different ways.